Hi class, so we're ready to start section 9.5, multiplication of radicals. So the first thing, concept 1, we're looking at the multiplication property of radicals, and this is something we looked at previously. So let's just recall this real quick. So the multiplication property of radicals says the following: let A and B represent real numbers such that the nth root of A and the nth root of B are both real. Right? Then the following is true. The nth root of AB is equal to the nth root of A times the nth root of B. Right? So remember, as long as we have the same root, and if we're multiplying two radical expressions with the same index, we can combine those into one radical, with the radicands being a product, right? And going this direction, we can, if we have a product underneath a radical, we can split that up into two separate radicals. So example 1, just practicing some of this multiplication, right? So the very first thing I would do for number 1a is to use the commutative property of multiplication to rearrange some of these factors. So we would have 4 times negative 2, and then times radical 6 times radical 3, right? So 4 times negative 2, right, I can write that as negative 8. And then radical 6 times radical 3, notice they have the same index. The index is 2 in both cases, right, because it's a square root. So that would be times radical 18, right? And then now we want to think about simplifying if possible. So off to the side, I can think about the prime factorization of the number 18. So we have 3 times 6, and 6 can be broken down into 3 times 2. Right, so 18 is equal to 2 times 3 squared. So there is a perfect square in here, so I know this is going to reduce. So this is going to be equal to negative 8 times the square root of 2 times 3 squared, right? Which equals, so applying that multiplication property of radicals again, would be negative 8 times the square root of 2 times the square root of 3 squared. Well, the square root of 3 squared is just 3, right? Because the square and the square root cancel each other out. So that would be equal to negative 8 times 3 times radical 2. And negative 8 times 3 is negative 24. So that's negative 24 times radical 2, right? And that's as simplified as we can go, right? All right, so same idea as in part A with part B. We're going to take this and just use the commutative property of multiplication and rearrange some of the factors. So we would take 3ab times negative 2, and then times radical b times radical ab, right? So the radicals have the same index, right? So I can apply the multiplication property of radicals again. And these first two factors, I can multiply those pretty easily, right? Something you've done lots of times. So this would be negative 6ab times radical ab times b, right? Well, that's just going to be negative 6ab times the square root of ab squared, right? And then I can apply the multiplication property of radicals kind of in reverse, right, in order to break that up. So that would be negative 6ab times the square root of a times the square root of b squared. Well, the square root of b squared is just b, right? So that would be negative 6ab times b times radical a. And then I can simplify because I have these two b's being multiplied, so that would be negative 6ab squared times radical a. Right? So then, so this next one, part C, we would take, we'd multiply 2 and 5 together, right? So in other words, what we're trying to look at is multiplying the things that don't have a radical in them together, and then multiplying the things with a radical together next, right? And we're specifically looking at things that have the same index, right? So they both have an index of 3. So we'd have 2 times 5 times the cubed root of 4ab times the cubed root of 2a squared b, right? And since these indexes match, we can rewrite that as just one cube root. So that'd be 2 times 5 times the cubed root of the product of 4ab times 2a squared b. Right? So 2 times 5 is 10. And then we need to simplify under the radicand. So that would give me 8 a cubed b squared, right? And then it's something important to just point out that the number 8 is equal to 2 cubed, right? 8's a perfect cube. So this would be equal to 10 times the cubed root of 8 times the cubed root of a cubed times the cubed root of b squared, right? So I just applied the multiplication property of radicals. And then I can, instead of writing 8, I can write 2 cubed. So this would be 10 times the cubed root of 2 cubed times the cubed root of a cubed times the cubed root of b squared. So then this would be equal to 10 times, so the cubed root of 2 cubed is just 2, and then the cubed root of a cubed is just a, and then the cubed root of b squared, I can't simplify that at all, right? That's already simplified. So then this would be equal to 20a times the cubed root of b squared. Right, so the next one, example 2, we have 5 radical 5 times the difference of 2 times radical 5 and 2. So if you notice, this setup is like the distributive property, right? So I'm going to take, this is just like if I had 3 times x plus 2, right? I would take 3 times x plus 3 times 2. I distribute the 3 through, right? Same idea here. I'm going to take 5 radical 5 and distribute through. So this would be the same thing as 5 radical 5 times 2 radical 5 minus 5 radical 5 times 2, right? So this would be equal to, so we can take 5 times 2, right? We can rewrite the order here a little bit. So in both cases, just rewrite the order of the factors a little bit using the commutative property of multiplication. And then 5 times 2 is 10, and then radical 5 times radical 5, that becomes just 5, right? Because that would be like radical 5 squared, right? So that those are going to undo each other. And then we'd have minus, so 2 times 5 is 10, and then radical 5. Right, so 10 times 5 is 50, so we get 50 minus 10 radical 5. Right, and so that's simplified. Right, now the next ones, we're still multiplying rational expressions together, but notice like example 3 and 4, this is set up like multiplying polynomials, right? So like for a and b, you're going to want to FOIL, and then example 4, you're taking a binomial times a trinomial, so you still multiply that out, but it's not exactly FOIL, right? Because FOIL is only when you take a binomial times a binomial, so it's a special type of multiplying polynomials. But the same general idea, right? We need to take each term of the first the first factor times every term in the second factor, right? So in other words, I need to take 2 times radical 3 times radical 3. And then I need to take 2 radical 3 times 2 radical 10. And then need to take negative 3 radical 10 times radical 3. And then lastly, take 3 radical 10 times 2 radical 10. So this guy, right? So radical 3 times radical 3, same idea, right? So radical 3 times radical 3 is like radical 3 quantity squared, right? Which is just 3, because squaring a square root, they just cancel each other out. So when I see 2 times radical 3 times radical 3, that's just 2 times 3, right? And then plus, and then 2 times 2 is 4. And then radical 3 times radical 10, that's radical times the product, 3 times 10, right? And then we'd have minus, and then that would be 3 times radical 10 times 3 in the radicand. And then lastly, we'd have minus, so 3 times 2 is 6. And then radical 10 times radical 10 is just times 10, right? So it's similar to before, right? They're going to cancel each other out. So then this becomes 6 plus 4 radical 30 minus 3 times radical 30 minus 60, right? And then these two things in the middle are like radicals, right? We looked at that in a previous section. So we can add those together. So this would be, just radical 30, right? Because 4 minus 3 is 1, so it'd be 1 radical 30. And then we would have minus, and then 6 minus 60 is negative 54, right? So we get radical 30 minus 54 for that one. The next one, so same idea, right? We're going to take x times radical y times 3x radical y, and then minus x radical y times 2y, right? So I got those two done. And then we take plus y times 3x times radical y, right? And then minus y times 2y. This first product, we can simplify that. So x times 3x is 3x squared. Right? And then radical y times radical y gives me just y. Right? And then I'd have minus. And then that would give me 2xy radical y. Right? There's nothing I can do to simplify that. I just maybe rewrote it in a nicer order. Same with this next middle term. We could rewrite that as plus 3xy radical y, and then minus, and then y times 2y is 2y squared. So then these middle terms, I can add those together. Those are like radical terms, right? So that would be 3x squared y plus xy radical y minus 2y squared, right? And there's really nothing else I can do there, right? So that's the final answer simplified. Right. So in the next one, we have 2 terms times a factor with 3 terms in it, right? So I like to use the distributive property here. So what we can do is just pick on the first one, radical t, and then multiply it by this whole second factor. So 4 minus radical t minus radical w, and then plus, and then just pick on the next term in the first thing. So that would be plus 3 times radical w, and then times, just copy and paste the second factor. right? So this becomes 4 radical t, right? Take 4 times t, and then we have radical t times negative radical t, so that's just minus t, and then radical t times negative radical w would be minus radical tw, right? Because they have the same index, so we could write that as one radical, and then I need to take the 3w times 4, so that would be plus 12 radical w, and then minus, so 3 radical w times negative radical t would be minus 3 radical tw, and then lastly we multiply 3 radical w times negative radical w, so that would become minus 3w, right? Because radical w times radical w just gives me w. And then let's see, I have this term and this term that are like terms, so if I combine those I get 4 radical t minus t. So negative 1 minus 3 is negative 4 radical tw, and then plus 12 radical w, and then minus 3w, right? And I don't think there's anything further that we can do there, right? So that's simplified. Right, so the next page, we're looking at concept 2. So I just have some notes here. We're looking at expressions of the form the nth root of a raised to the nth power, right? So we can say the multiplication property of radicals can be used to simplify an expression of the form the square root of a quantity squared, right? Where a has to be greater than or equal to 0, right? So the square root of a quantity squared, right, that's equal to radical a times radical a, which would be equal to the square root of a squared, right, which of course would just be equal to a, where a is bigger than or equal to 0, right? And we have to have that condition that a is greater than or equal to 0, because if I had the square root of a negative number, then we wouldn't have a real number, right? So then we could say that this logic can be applied to the nth roots, right? So in other words, if we have, so if the nth root of a is a real number, then the nth root of a, all raised to the nth power, is simply just a, right? So those cancel out, right? So example 5, we have three of these, right? So like part A, we have the square root of 14 squared, right? Well, the index is 2, right? So anytime, you know, the index of the radical and this exponent match, and it's in this format, you're left with just what's in the radicand, right? They cancel each other out. So this is just 14. The next one is just equal to q, right? And then part C, this one is just equal to 3z, right? Because these match, right? So then concept 3, we want to look at some special case products, right? So this is just a reminder of some special case products when we looked at multiplying polynomials, right? So if I have a plus b quantity squared, that's just a squared plus 2ab plus b squared. If I have a minus b quantity squared, that's equal to a squared minus 2ab plus b squared. And then lastly, we also have the difference of squares, right? A plus b times a minus b is equal to a squared minus b squared. Right? So we're looking at these in example 6 and 7. right? So radical a minus 5 quantity squared, that's like this one, the second one that we had written down. So that's just equal to, so just using that equation, that's just equal to so this is like my a and this is like my b, right? So the first part quantity squared minus 2 times the first part times the second part plus the second part squared, right? So this would be equal to, so the square root of a quantity squared is just a, and then this would be equal to minus 2, well, 2 times 5, we can write that as 10, right? So that'd be minus 10 radical a, and then 5 squared is 25, so plus 25, right? So we get a minus 10 radical a plus 25. Part B is just like the first one that we had written down, right? So this would be equal to the first part, quantity 4 radical x squared, plus 2 times the first part times the second part plus the second part squared, right? Because this is like my a and that's like my b, right? So this would be equal to, so pay attention here because we have a product quantity squared. So remember, if I have like xy quantity squared, this is equal to x squared y squared, right? I have to take each factor raised to the power. So this would be equal to 4 squared radical x quantity squared plus, and then 2 times 4 is 8, and then radical x times radical 3 is the square root of 3x, right? Just using that multiplication property of radicals. And then square root of 3 quantity squared, right? That's just going to be plus 3. Right? So then 4 squared is 16. Radical x squared is x, so we get 16x plus 8 radical 3x plus 3. Right? So that's simplified. Right? So now we're ready for the last page, page 4. So we have here multiply the conjugates together, right? So conjugates is where you're taking like a plus b times a minus b, right? These are referred to as conjugates of one another, right? So in other words, when we multiply conjugates, remember we get the difference of squares, right? So radical 5 plus 3 times radical 5 minus 3 is going to be equal to the first thing squared minus the second thing squared, right? The difference of squares. So this is equal to, so radical 5 squared is just equal to 5, and then 3 squared is 9, so we get 5 minus 9, which is negative 4, right? So then the next one, same idea, right? I just take this first thing, so 1/2 square root of a quantity squared, and then minus the second part squared, right? So we got to be careful with the exponent rules. So since I have, a product of two things being squared, I have to take each thing to the power. So same thing with the next one. Right? And don't forget, when you have a fraction raised to a power, you gotta distribute the power to the numerator and the denominator, right? So the first one, that would be 1 squared over 2 squared, right? Times, and then radical a squared is just a, and then we have minus, that would be 2 squared over 5 squared, right? Just following the rules of taking a fraction to an exponent, and then the square root of b squared is just b. So then this becomes 1/4 a minus 4/25 b, right? And that's simplified. Right. So then the very last part of this section, the concept 4, is multiplying radicals with different indices, right? We have different indices, right? So like here the index is 2, here the index is 3, here the index is 4, and here the index is 3. So they don't match, right? But there are some ways that we can rewrite these to combine it into one radical still, right? So the general idea is thinking about this in terms of rational exponents. So the first one, right, we have the square root of x, that's x to the 1/2 power, right? And then we'd have times, and then the cubed root of x is x to the 1/3 power, right? So just following our basic exponent rules, when I have the same base and I'm multiplying, we add their exponents. So this would be x to the 1/2 plus the 1/3, right? Which equals, I need to get a common denominator. A common denominator of 6 would work. So this would be x to the 3/6 plus 2/6, which equals x to the 5/6 power, right? So then applying properties that we used before with rational exponents, this would become the 6th root of x to the 5th power, right? Or in other words, if that was a little too quick for you, we could write this as x to the 5th quantity raised to the 1/6 power, right? Because this is equal to x to the 5 times 1/6. And then so we can go from here to the answer I just jumped to, right? Right. So this last one's a little harder, and I can show you the technique for this. So the very first factor, we could rewrite that as a rational exponent, right? That would be a to the 3rd all to the 1/4 power, and then times b to the 1/3 power, right? And then remember, when you have a power to a power with exponents, we multiply. So this would be a to the 3 times a 4th times b to the 1/3 power. Well, 3 times a 4th is just 3/4. So this would be a to the 3/4 power times b to the 1/3 power. Right? So now what the trick is to get the same denominator, right? So a common denominator we could get between 4 and 3 would be 12, right? So we could rewrite this as a to the, here I would multiply by 3/3. So that would give me a to the 9/12 times b. And then here I can multiply by 4/4, right, to get a common denominator of 12. So that gives me b to the 4/12. So then this would be the same thing as a to the 9th all raised to the 1/12. Oops, hang on, sorry. There. So this would be equal to a to the 9th all raised to the 1/12 power times b to the 4th all raised to the 1/12 power, right? So applying exponent rule, this would be the same thing as a to the 9th, b to the 4th all raised to the 1/12, right? It's like doing the power of a product rule kind of backwards, right? So then this would be equal to, so now just using the idea of rational exponents, this would be the 12th root of a to the 9th, b to the 4th, which is the simplified answer, right? All right, so make sure if you have questions, make sure you're getting a hold of me. I'll be happy to help. All right, thanks.